Hello, we are on page 255. This is Module 2, Topic 2, Lesson 3. After this lesson, we'll be halfway through this topic, so we'll be taking a mid-topic quiz. Anyways, I think we're pretty familiar with, I think, the math behind the topic for today's lesson. The only thing is we're kind of interpreting word problems, so that takes some a little bit of analysis. But here, activity 1, it says choosing independent and dependent quantities. I do want to remind us though that, I'm going to write this off to the side, that the rate of change or the slope is always the dependent variable over the independent variable, or y over x, change of y over change in x, or rise over run. So we're going to have to identify in these different situations which one is dependent, which one is independent. Anyways, so from there, we'll need a couple of points. Let's look at the context here on page 255. It says, Josh took a road trip with his family to visit Yosemite National Park in California. The table shows some information about their trip. They drove a total of 2,600 miles. Total cost for gas is $200, and they used up 80 gallons of gasoline. So think of those milk gallons, 80 of those, so quite a bit of gasoline. This context is going to be used for this page and also the next page, and we're going to interpret it in kind of two different ways. So the first one, number one, after they arrived, Josh was curious about how many miles per gallon. Let's highlight that. So miles per gallon their car got on the trip. So miles per gallon. I'm going to write that off to the side over here. I'll put MI over GAL. So that already there kind of tells us, which one is dependent over which one is independent. So it says, given this question, what are the independent and dependent variables? So we're saying that the numerator here is dependent. The numerator here is miles. So let's go and put that, let's put that right here. So dependent is miles, and independent, just like I'll highlight this in a different color, put this in red, independent is gallons. Okay. And for number 1B, we're going to write two ordered pairs, given the information that we have. And then we'll also talk about the meaning of those ordered pairs. So when we write an ordered pair, we're always going to start typically we'll start at 0. So in this case, I'd like for you to put the coordinate 0, 0. So how do we interpret this? This is, we'll put 0 gallons for 0 miles. This is just us just barely starting our trip. The other thing that we have here is, we'll say, since the independent variable is x and the dependent variable is y, and an order pair is always x comma y. The other thing we have, x gallons, well, what do we have here that represents gallons? We have 80. And here, what represents miles? That is 2,600. Okay, so what does that ordered pair mean? This means, 80 gallons, and I should abbreviate it, to travel 2,600 miles. Oops. Okay, and then just want to be clear here, let's actually write out x and y. So x is gallons and y is miles. Okay, this is just us setting it up before we figure out any rate of change. Okay, and that's what we're going to get to the next part, C. So it says determine the rate. When we say rate, you could literally just translate this to be slope, Slope means how much we move, how much we increase, decrease. A rate is exactly the same, except we use slope when we have a graph. We don't have a graph here, so that's why we're saying rate. So what I like to do here is I like to line up the ordered pairs vertically. When you set up your slope formula, that is, I'm only going to write this once, y1 minus y2. The y's we subtract on top, and then the x's we subtract on the bottom. So what you can do here, you can just subtract the y's, that's these two values, and then divide that by subtracting the x's, that's these two values. I'll go from bottom to top because I think it's easier to do 2,600 minus 0. So the rate is 2,600 minus 0 over 80 minus 0. And this calculation, not too bad. We'll get 2,600 over 80. And then, so actually, let's just write that. So what does this represent? This represents exactly what we use, 2,600 miles for every 80 gallons used. Right, and that's considering that we're going at a constant rate. So we'll make that assumption here. So D, how many miles per gallon did their car get on the road trip? So miles per gallon. So instead of miles per hour, right, that's looking at speed, we're looking at how much we're using per gallon. So that is a rate. So what we do here is that's you just simplifying our rate. Now you can try to simplify this, or we have numbers that end in 0. So instead of doing 2600 divided by 80, you could do 260 divided by 8, right? And you can set up long division there. For the purposes of being efficient, though, I'm going to put this into our calculator. You're welcome to do this as well. 2600 divided by 8, or sorry, 260 divided by 8. All right, and that is 32.5. Okay, so that represents that this is, right, 32.5 miles per gallon. To put that in like perspective, like a marathon is 26 miles, so it's a little bit over a marathon. And I'm pretty sure 32.5 miles, you can pretty much get anywhere in Las Vegas. Las Vegas isn't that big, but anyways, to give you an idea of like how big that represents, okay. And again, I want you to think of the y-intercept as where we begin, the slope as how much we're moving, meaning how much we're increasing and decreasing. So a couple of things that it's asking us. For each context, complete each task, we're going to identify the independent and dependent variables. We're going to write the ordered pairs of 2 points, so ordered pairs, and explain what each of the ordered pair means, so the meaning. So we're going to write a sentence there, and then we're going to determine the rate. So just like we did for the last one, but we are going to go through a couple of these. We're going to go through 1 and 3. We'll skip 2. All right, but let's keep our calculators in. So the hardest part here, I think, is writing the ordered pairs. But let's try to interpret it from this context. So what's independent, what's dependent, first of all. So it says Bella's Pizza Shop charges $9 for a large pizza, and any toppings ordered cost extra. Bruce ordered a large pizza with 3 toppings. That cost a total of $12.60. What is the cost per number of toppings for a large pizza? So let's highlight a couple things that are important here. We know that these numbers are important. So a pizza just costs $9 just to start, so that's where we begin. And then we also have that we have 3 toppings, and that those 3 toppings raise the price, right? It's now $12.60 versus 9 cents, or sorry, dollars versus $9. And we want to figure out what is the, I'll put this in a different color, cost per number of topping. Just say cost per topping. Okay. Now, what we're going to have to do here is we have to look at the increase. So what you can do, you don't have to set this up using the formula, but if we go from $9 to $12.60, what is that difference? And whatever that difference is, we're dividing by 3 since there are 3 topics. That's how you could find that out. But we'll go through this more logical, I guess, way of going about it. So in this case, independent and dependent. Okay. So it says cost per topping. That actually gives you the fraction. Since we know it's always dependent over independent, cost per topping. Okay. So we're going to, so dependent, that's the numerator. That means it's the cost. I'll put cost right here. And the independent, that's the denominator. That tells us its number of toppings. Okay, great. Now that also gives me an ordered pair too, because the ordered pair is always x comma y. So let's think about, we're always going to, like I said, we're always going to start at 0. So let's think about 0. You can't have 0 pizzas, but we can't have 0 toppings here. So a pizza with 0 toppings, how much does that cost for y? That is $9. So that gives us a little bit of something to interpret there. Actually, let's write that in while we're at it. We'll say a pizza with 0 toppings, I'm going to abbreviate, costs $9. And then the other thing here, so instead of 0 toppings, there was some information with 3 toppings. 3 toppings, and that cost us $12.60. I'll put 12.6. It means the same thing. This is a pizza with 3 toppings, costs, $12.60. All right, now comes the part where we are figuring out the rate. We're going to have to squeeze this in here because we're running a little bit out of room. Okay, so the slope or the rate, change of y over change in x. So let's subtract the y values. Now it actually doesn't matter. You could do 9 minus 12.6. As long as for the other one, you put 0 minus 3. Right, you start with the same point. Or I could do 12.6 minus 9 as long as I do 3 minus 0. And you know what? I'll do it that way. 12.6 minus 9 divided by 3 minus 0. I'm just going bottom up, bottom up. We got to start at the same place. We talked about this in a previous lesson. Anyways, what's 12.6 minus 9? Well, what's 12 minus 9? 12 minus 9 is 3. I got that 60 cents on top of it, so it's 3.6. And then 3 minus 0 is 3. Now this, we can do some mental math here. We're not going to use a calculator. How many times can 3 go into 3? It's 1. And then how many times can 3 go into 6? That's 2, so it's 1.2. This, answering our question, what is the cost per topping? It is $1, and we'll put a 0 here. 2/10 is the same thing as 20 hundredths. $2.20 per topping. Oh, sorry, $1.20 per topping. All right, good there. Now, not too bad, right? We had to identify what is independent, dependent, and that came from the question. That helped us quite a bit. We wrote down these ordered pairs, right? So that is maybe kind of, there's a level of complexity to it, so we have to be careful with how we set that up. We know how to subtract, set up as a fraction, simplify that fraction, and we answered the question. Good. Let's go to number 3. We'll skip number 2. Okay. This is talking about Melanie. So Melanie, is she a baker? Yes. So bakes 15 dozen. So dozen is 12. So 15 dozen, you have to multiply, 15 times 12. 15 dozen breakfast rolls in 3 hours. Right. So that's a key piece of information there. After 8 hours, she has baked 40 breakfast rolls. At what rate does Melanie bake breakfast rolls per or each hour? Okay, let's write that out. So again, it's dependent over independent, and this is rolls per hour. Okay, now the first thing we have to do, right, we have to identify the independent dependent variable. We kind of already did that here, but let's write it out explicitly. Right, what is independent? Independent is hours, so time in hours. And dependent is number of rolls baked in terms of dozen. We'll just say number of rolls, and I'll put a dozen in parentheses, just so we know what does it represent. Okay, now comes the time where we're writing ordered pairs. We typically start at 0, 0, or 0 for the independent variable, but we're given quite a bit of information. So let's write that out, or let's highlight this. 12 dozen in 3 hours. That looks like it's an ordered pair. And then separately, 8 hours, she's baked 40 dozen. Okay. Now, if you're not sure how to write this, whether it's the first one's going to be 15 and using in 3, is it 15.3 or 3.15? All right, well, let's use some clues here. It's always x comma y. We know that the independent variable is x and the dependent variable is y, just because it's always y over x. So we're going to have time be the x variable. So time in that case is 3 hours. And then 15 dozen, we'll just put 15 right, for the y variable. So this is represented as 15 dozen, or sorry, 3 hours. And I'll just put comma. 15 dozen rolls baked. I could have wrote that a lot better, but we'll just keep it like that. And then the second thing here we're going to put is what I have in orange in terms of time, 8 hours, 40 rolls baked. Or sorry, 40 dozen rolls baked. Okay, now comes the time that we're going to set this up. Let's subtract our y's. So we're going to put, I'll do 15 minus 40. I'll start at the top one this time. That means for the x, I got to start on the top one. So this is 3 minus 8. Okay, let's simplify. 15 minus 40. All right, different signs, so you have to subtract them. 15 minus 40 is a negative 25. And then 3 minus 8, same thing, different sign, subtract, keep the sign of the bigger number, it's a negative 5. We can simplify that, we don't need a calculator. This is, negative divided by negative is a positive, and 25 divided by 5 is 5. So our final answer here is 5 dozen rolls per hour. Or, right, what's 5 dozen, right? A dozen is 12, 5 times 12. We could also put that this is 60 rolls per hour. Okay. All right, good there. Right, so 60 rolls per hour, right? That's quite a bit for every hour. That's if you were to put that in terms of minutes, that's 1 roll per every minute. So that seems like a pretty efficient thing that they got going on in this bakery. Okay.